So we've left off, we were dealing with trig identities and finding missing parts of a triangle. So we're going to look at right triangles. Now if we're given right triangles, remember triangles have 6 parts. Triangles have 3 sides and 3 angles. Well, since we know that this is a right triangle, then we already know one of the angles because it's the right angle. So what's left to figure out, what's unknown, what's known is we have the right angle. What is unknown is the 3 sides and the other 2 angles. Of these 5 unknowns, if I am given 2 of them, as long as both of them are not the other angles, I can find the other 2. Basically, if I am given 3 parts of a triangle, as long as it's not all 3 angles, I can find the other 3 parts. So I have to know at least one side. So I have to know 1 or 2 sides. And 1 or 0 angles. So we're going to start off with what happens if I am given... We're assuming that we know the right angle, so I'm not going to write that down each time. What happens if we are given 2 sides? And we want the 3rd side. I start with this one because this is the easiest one, and we've known how to do this one since fall. In fact, I'm going to move this over just a touch. What if I give you that this is 5 inches and this is 12 inches? And I'm asking you to find side x. That's the square root of a squared plus b squared, right? A squared plus b squared equals c squared. Comes up to be 13. Or if I give you that this is 12 inches and this is 20 inches. And this is x inches. How do I find x here? Square root of 20 squared minus 12 squared. Why is it minus? Because I'm given the hypotenuse. Yes, I'm looking for a leg. So that comes out to be 16. So that part's pretty simple. If I'm given 2 of the sides and I know there's a right angle, I can find the 3rd side just by using my Pythagorean theorem. A squared plus b squared equals c squared. Then obviously I used shortcut versions of it here to make the calculation a little speedier. What happens if we're given one side and one other angle? Again, assuming that we know that there's a right angle there as well. And we want the 3rd side. Well, we want the other sides. Well, when we're given a right triangle here, if I give you one of the other angles, if I tell you that this here is 40 degrees, I am in essence giving you all of the angles. Because this one here has to be what? 50, right? 180 minus 90 is 90, minus 40 is 50. You have to add up to 180. So if I give you one angle and I already know the right angle, that's 2 out of the 3 angles. And the 3rd angle can be found really quickly with subtraction. if I give you that this is 30 inches, and I want to find A and B here, I look at the angle I'm given. 40 was the angle I was given, so I'm going to be looking at this angle. That's the angle I'm going to use. Now I need to identify the parts of the triangle, the opposite, the adjacent, the hypotenuse, according to that angle. Well, the easy one to find is always the hypotenuse. What's the hypotenuse here? 30 is the hypotenuse. Now the opposite and adjacent depend on what angle I'm using. So I'm going to commit to using this 40-degree angle. That's the angle I'm going to use. If I am trying to find side A is what side of this? The opposite. So again, that thought process is very important. I was given the hypotenuse. I'm trying to find the opposite side. So I'm working with hypotenuse and opposite. Looking at my trig functions. What trig function involves the hypotenuse and the opposite side? Sine of an angle is opposite over hypotenuse. You could also use the cosecant, but the cosecant does not appear on our calculator, so we don't want it. Now I fill in what I know. I know the angle, so I put 40 degrees in there. Do I know the opposite side? No, that's side A. That's what I'm looking for. Do I know the hypotenuse? That's the 30 inches. So when I am looking for a side, I know the angle. I make this into a proportion by putting that over 1. So I make it sine of 40 over 1. Now it's a proportion. And to solve a proportion, I can just cross multiply. Sine of 40 times 30 and then divide by the 1. So sine of 40, I make sure I close those parentheses, times 30 divided by 1. Realistically, I don't have to divide by 1, but I'm doing it just for good form. So I've got 19.284. So this is 19.284 inches here for side A. To find side B, I'm still committed to the 40-degree angle, so side B is which side? The adjacent side. So now I was given the hypotenuse, and I am looking for the adjacent. What trig function deals with hypotenuse and adjacent? Cosine does, or the secant, but we're going to do it with the cosine. So I write down my definition of cosine. Cosine is adjacent over hypotenuse. I know the angle, so I put 40 degrees in for the angle. The adjacent side is side B, that's what I'm looking for. My hypotenuse is 30. So once again, I put that over 1 to make it a proportion, and I cross multiply. Cosine of 40 times 30 divided by 1. Cosine of 40, make sure we close the parentheses there, then times 30 divided by 1. 22.981. So this is 22.981 inches. I have found the other sides. Or I could be given something like this. Pretend that side's straight. Where I'm given that this angle up here is 59 degrees. And I'm given that this side here is 27 inches. Now again, I automatically know that this angle here is 31 degrees. How do I know that? Add up to 180 here. Also, you know, these two angles have to be complements, so I can just subtract from 90, really. I am looking now for side A and side C. To find C, Again, I must commit to the angle I'm going to use. I was given the 59-degree angle, so I'm going to commit to using that. Then I look at the side I am given. I was given the 27. What side is that? That'll be the opposite side. If I'm finding C, C is the hypotenuse. So I'm given the opposite and I'm looking for the hypotenuse. Opposite and hypotenuse make what trig function? Sine. So I write out my definition of sine. Sine theta is opposite over hypotenuse. Then I fill in my information. The angle I'm going to use is the 59. Opposite of 27 over the hypotenuse of C. Again, I'm looking for a side. I put this over 1 so I can cross multiply. Here it's a little more important that I do that because now C is on the bottom. So I have to cross multiply here. 1 times 27 is 27 divided by the sine of 59. So 27 divided by the sine of 59. 31.499. Or negative 59. Yeah. So that's 31.499 inches. To find A, well, I still know the opposite side. A is the adjacent side. Opposite and adjacent make tangent of an angle is opposite over adjacent. So I fill in what I know. I know my angle is 59 degrees. Opposite is 27. My adjacent side is A. So I'll put that over 1. It's going to be cross multiply. 1 times 27 divided by the tangent of 59. $16.223. What do you think? Not terrible? Did you say you're learning? Learntable? So I want you to find angle B, side A, and side C. In your notes, I'll pause. Angle B is what? 72 degrees. Good. Just subtract from 90. 18 from 90. Side A is going to be found because it is the, if we're committing to the 18-degree angle, A would be the opposite side. And we are given here the adjacent side. Opposite over adjacent is tangent of an angle. So we fill in tangent of 18 degrees equals A over 58. And we cross multiply and divide. Tangent of 18 times 58 divided by 1. $18.845. What'd you guys do? Oh, so you did 58 over A instead, and it was tangent of 72.
Well, no, I still did tangent.
Yeah, it'd be tangent of 72 equals 58 over A. Right? Yeah. Yep, that all works. So I'm still looking at the 18 here for mine. I'm going to use cosine because I have the adjacent is given, and I'm looking for the hypotenuse. You probably use sine because you had opposite hypotenuse, right? Cosine of 18 equals 58 over C. Put this over 1. cross multiply cosine of 18. Oops, I can't do it that way. I've got to do 1 times 58 divided by cosine of 18. You probably had 58 divided by, or
Sine 58 divided by 1.
Sine of 72. Yeah. Same difference. 60.94 or 60.985. Why did that work, by the way? Well, cosine of 18 is 0.95105, right? Sine of 72 is 0.95105. Remember, the cosine of one angle is equal to the sine of its complement. Since those are complements, they work. So now, what if I am given two sides, and I ask to find, I want the angles. So I might be given 18 inches and 32 inches. Well, which angle do I want to find, B or A? A. So we're going to commit to finding angle A. So then we were given two sides. The 32 is which side? Hypotenuse. And the 18 is the adjacent. So what trig function deals with hypotenuse and adjacent? Cosine of an angle is adjacent over hypotenuse. So cosine, we don't know the angle, it's angle A, is equal to the adjacent of 18 over the hypotenuse of 32. When we are looking for an angle, now I'm going to note up here, all these calculations, we knew the angle in both of them, right? Down here, the angle is what we are trying to find. When we are trying to find an angle, we have to use an inverse trig function. This is the cosine, so we have to use the inverse cosine. So that tells us that A is the inverse cosine of 18 over 32. Make sure you close the parentheses when you type that in. 55.77 degrees. Which means this angle is 34.23 degrees. How did I get 34.23? Perfect. Subtracted from 90. I want to find these angles. Which angle do I want to find first, A or B? A, okay? So we're committing to angle A. According to angle A, the 22 is which side? That is the adjacent. And the 9 is the opposite. Opposite and adjacent make tangent. Tangent of an angle is opposite over adjacent. So let's fill in what we know. We don't know the angle, but it is angle A that we're looking for. So tangent of A. Opposite is 9, adjacent is 22. Since we are looking for an angle, we use an inverse. It's a tangent, so we use an inverse tangent. So that tells us that our angle A is equal to the inverse tangent of 9 over 22. So second tangent 9 divided by 22. Make sure you close the parentheses again. 22.25. So 22.25 degrees, which makes this one 67.75 degrees. Yay or nay? See? Close enough. Find little a, big B. Okay, so finding little b is actually going to be pretty simple. Or little a, I was going to say, this should have been little b, right? Finding little b. Finding little b would be simple here. That's just going to be the square root of 59 squared minus 50 squared. Otherwise known as 31.32. So which angle did you find first, A or B? B? Okay, so our tiebreaker goes with B. For looking at B, we have two known sides. I'm not going to use the 31.32 because I just calculated that, so there's round off in it. If I reuse it, there's going to be round off in that next answer. So I try to avoid using answers that I just calculated because there's round off in them. The other thing is there's a possibility I made a mistake. And so, yeah, I know. Very slim possibility that I made a mistake, but it's there. I'm speaking in terms of me being in your place as a student, of course. There's a possibility that you have made a mistake there. How's that? Okay. So anyway, angle B, the 50 is what side? The adjacent. And the 59 is hypotenuse. So we are looking at a cosine. Cosine of an angle equals adjacent over hypotenuse. So then we'll put in the cosine of angle B is 50 over 59. And since we are looking for the angle, it's going to be an inverse trig function, so inverse cosine. So B equals the inverse cosine of 50 over 59. So second cosine 50 divided by 59. 32.06. So that is 32.06 degrees. Okay. And that is the holdup on these generally. Hypotenuse is easy to find. If this is the angle, the leg that touches the angle is adjacent. Opposite is across from it. Opposite does not touch. Adjacent thing is next to, right? Yeah, think of it this way. If this is a street, come on. Yeah, I'm being fancy. Put my yellow line down the middle of the street. And here is the building we're talking about, right? Then over here is building A. And here is building B. If I asked you which building is adjacent to building X, what would you say? B. Because it's next to it, right? Which building is opposite building X? Because it's across from it. These two buildings are next to each other, they touch each other. Same thing here. This angle and this side are next to each other, they touch each other. This side's across the triangle from B. Pretend that's flat ground there. And last semester, actually the beginning of this semester even, we talked about this infamous tree. This infamous tree that we were trying to cut down and wanted to know what height it was, right? And we used shadows last time to find it. Well, this time we're going to use a theodolite. Is it a theodolite or something called theodolite is called? It's like a surveyor's transit, only it's capable of doing angles as well rather than just level. So let's say we have it set up here. Here's our scope, right? The height of our scope off the ground here is 5 feet. And we shoot through the scope. We sight in the top of the tree. We have an angle of elevation here of 28 degrees. Now, the biggest question, of course, is where's our triangle? Well, and I do have to give you one more piece of information. Let's say I measure from the center of the trunk of the tree over to the scope, and I get that we are 90 feet away. I want to know how tall is the tree. Well, the triangle we're forming here goes from the scope to the tree and up. This side here is still the 90 feet. This side here is not H, but we're going to find it anyway, so I'm going to call that X for now. X is which side? The opposite, the 90 is the adjacent. So I am dealing with a tangent. Tangent of an angle is opposite over adjacent. I know my angle is 28 degrees. My opposite side is X, that's what I'm looking for. My adjacent side is 90. Since I am looking for a side, I know the angle, so since I'm looking for a side, I make it into a proportion. That's why I put it over 1 here, so it's a proportion. And I cross multiply and divide. So tangent of 28 times 90 divided by 1. So tangent of 28, make sure I close my parentheses, times 90. I don't need to do the divided by 1. 47.85 feet. Is that the height of my tree? No, what do I still need to do? Add my 5 feet here. So 47.85 plus 5 is 52.85 feet. This is the height of my tree. What do you think? Yeah? That's an angle of elevation. What's that? Not horrible? Better than a sharp stick in the eye? we send Tate out to sea, right? We've got Jake waiting for Tate to come back. And Jake sights Tate in. We're going to go to the front of the ship here. The bow of the ship, yeah. Yes, it is. And he has something you'll talk about next year when you get into the surveying class. That's called stadia theory. Within these scopes there are stadia. You can actually use it to estimate a distance. So if you know that Tate is 6 feet tall or whatever, you can use the stadia to estimate, okay, that means he's this far away because he's this many stadia within the scope. So, using that, Jake estimates that Tate is 380 feet away. And the scope tells Jake that the angle of depression here is 41 degrees. Now that is an angle of depression. And by depression, I mean it's an angle going from the horizontal down, not that Jake misses Tate that much that he's depressed. Jake wants to know how far it is down to the water. Can he jump for it and survive? If the scope is once again, because he's looking down, let's say the scope is only 4 feet up, so he can see down into it. How far is it from the cliff down to the water? Well, our triangle here is going to look like this. There's my right angle. We're going to call this dimension A because that's going to be a little bit bigger than X. The 41 degrees is actually going to be down here. How can I make this angle 41 degrees? Yeah, those are both horizontals. Horizontal is parallel to other horizontals. So these two angles have to be equal. So now this would be the opposite side, and this is the hypotenuse, which makes it a sine. We plug in the 41 degrees. The opposite side is A, and our hypotenuse is 380. Again, since we're looking for a side, we make it a proportion. We're going to cross multiply and divide. Sine of 41 times 380 divided by 1. So sine of 41, it's important that we close up parentheses, times 380 divided by 1. 249.30. Which we have to subtract the 4 feet to give x is 245.30 feet. So you think you can survive a 245-foot jump into the water? Oh, it's a good 6-7 feet deep. Yeah, do it. It's just deep enough to make it harder to recover the body. You go feet first, yeah, jam your legs up to your chest. That's just like saying if you jump off the Empire State Building feet first, it'll just break your legs. Okay, now we're about a minute, 2 minutes early for our break. Let's go ahead and take our break anyway. We'll come back and we'll talk more about this stuff. Roll. So now our next application we're going to look at is with this Theodolus again. And what we're going to look at is, let's say we have a feature that we want to line up with. Let's say there's a house here. And we want to build a shed over here that lines up with this house. So what we want it to sit straight. You know, we don't want it to sit like this or anything like that, right? So what we're going to do is we're going to set up this mighty Theodolus. We're going to set it up right here, and we're going to adjust it until we sight right down the edge of the house. Okay? Does that make sense? So you move it. A lot of times what they'll do is they'll actually mount something that sticks out like a half an inch from the side of the house down here and a half an inch from the side of the house down here, so they can actually line them up almost like sights on a gun through that scope. So you've got that lined up perfectly. So you know that this line here is the perfect line to the side of that house. You set the first corner of this building right there. You want this building to go 28 feet this direction. And 40 feet in this direction. So like I said, we have located this corner of the building. We know where that's going to be. So from our scope, we rotate our scope so that we're sighting that corner. The scope gives us an angle here of 51 degrees and a distance from the scope to that spot of 62 feet. What I want to do is I want to figure out how far over that is. I'm going to call this my X coordinate and my Y coordinate. How do I do that? I'm going to draw a triangle down here. This is 51 degrees. This is my right angle, and this is 62 feet. I want to know X and Y. Tell me how to find X and Y. Well, let's find X first. According to my angle of 51, X would be which side? Opposite. Of course, the 62 that I know is the hypotenuse. Opposite and hypotenuse are sine. So sine of theta. Opposite of hypotenuse. Put in my 51 degrees. Sine of 51 is my X over my 62. Put this over 1 so I can cross multiply and divide. Sine 51. Make sure I close my parentheses. Times 62 is 48.18. So X up here right now is 48.18 feet. Let's find Y. Y over here, of course, is the adjacent side, which means we're dealing with a cosine. Cosine's adjacent over hypotenuse. So it's the cosine of 51 degrees equals Y over 62. Put that over 1 so we can cross multiply and divide. So cosine of 51 times 62 divided by 1. 39.02 feet. So this is 39.02 feet. So now I want to find this coordinate here, this corner here. I want to locate it from the Theodolus. Well, I know that the distance from here to here is going to be what? 48.18. That's not going to change. I know that this distance from here to here is going to be 11.02. How did I get that? Subtracted the 28 from my 39.02. So now I've got to rotate my theodolite. Theodolite or theodolite, they're both terms for a similar instrument. So I'm looking at that triangle right there. So I'm going to pull that out so we can look at it. That triangle has sides 11.02 and 48.18. I want to know this angle and that side. This side's going to be really easy. It's the square root of 48.18 squared plus 11.02 squared, correct? So 49.42 feet. The angle, I'm dealing with opposite and adjacent, is going to be a tangent. Filling in what I know, I'm looking for that angle. Opposite side is 48.18. Adjacent is 11.02. I'm looking for an angle, so I do an inverse. It's a tangent, so of course it's an inverse tangent. Second tangent. .12 degrees. So that is saying is we set our theodolite at an angle here of 77.12 degrees and a distance here of 49.42 feet. Normally we would write that like this, that this is 49.42 feet at 77.12 degrees. Make sense? So now what if I wanted to locate this point? Well, I have a triangle there, so it looks like this. Let's pull that triangle out and talk about it. I know this side of the triangle here is 11.02 feet. Right, that's just the same as this side here. Right. How about this side here? 48.18 plus 40, so it's 88.18. So I'm looking for this angle and this side. So this angle and this side, right? Pythagorean theorem and inverse tangent, right? Okay. What I want you guys to do is I want you guys to try a little bit different one of these. I'm going to set this one up a little simpler with a little simpler numbers for you. Here's our street, right here. We're going to set up right on the edge of the street, right on the curb, sighting down the curb. So we've got our straight line here down the curb of the street. From our theodolite, which is right here, let me get a red dot. We're going to set the first corner of our building a distance of, let's call this 30 feet for a minimum setback. And this distance here ends up being 50 feet. This building is 32 feet by 48 feet. Pretend it's square. What I want you to do, I'm going to call this points A, B, C, and D. For point A, the distance from the Theodolus to that point, we're dealing with that triangle, right? So we have this triangle that's 30 feet here, 50 feet here. Here's the angle I'm looking for. So what I want to find is I want to find this angle and this distance. Well, that distance is the square root of 50 squared plus 30 squared, correct? So 58.31 feet. This angle is the inverse tangent of 30 over 50. .96 degrees. So point A, located from that Theodolus, is 58.31 feet at 30.96 degrees. Does that make sense?
Yeah.
So I want you to locate B, C, and D for me. Let's look at point B. Point B is going to be this triangle here.
Yeah.
And that triangle will be 50 down here. And what's it going to be here? 62. So its length is going to be the square root of 62 squared plus 50 squared. Let's try that again. 62 squared plus 50 squared. 79.65 feet at the angle is going to be the inverse tangent of 62 over 50. .12. How many of you had that? Okay, once you had the 79, you use the sign. Yeah, that works. Like I said, we prefer not to use that because that's rounded off. So the 62 and 50 we know are exact. .38 would be this angle.
Yep, I found both.
Okay. Sure. So this is point D actually that I'm doing here. This is 30 feet. What's this down here? 98, because you have the 48 feet for the building. So this, of course, is the square root of 98 squared plus 30 squared. Right? I'm doing point D. So that's 102.49 feet at, that's going to be the inverse tangent of 30 over 98. .02 degrees. How many of you had that for D?
Yeah.
Cool.
Learn something from it, so you know. Learn something.
Okay, well that helps. So for point C, this is point C here, this is 98 feet, this is 62. So we have the square root of 98 squared plus 62 squared. .115.97 at the inverse tangent of 62 over 98. .32 degrees. What do you think? Good stuff? Ready to do this on a quiz tomorrow?
Yeah.
Or Thursday?
This wasn't that bad. Not that bad.
It's usually not bad if you know what you're doing.
That was really bad when you know what you're doing.
Now, someone should put that in a book now.
You see, that seems like something you figured.
There you go, page 705. I believe it is exercise 34-3. It's either 32-3 or 34-3. I think it's 34-3. Then page 708, 34-4. Finding missing parts of right triangles. Thursday, there will be a quiz at some point. Just so you know.
We get preview of this quiz? This is it?
This stuff is pretty much the preview.
Very kind of you.
We have to practice